I'm Rui Huami. I'm from Yang'an University. Nice to meet you and thank you for your invitation. Today, I would like to introduce a stage achievement of our research to you. The title of my presentation is Family's Second Childbearing Decision under Social Welfare Environment. I think this is demography research. It's just a very simple application of game theory. So we know that most Chinese families still would like to have at least one child to meet their spiritual and emotional needs. But when it comes to whether to have the second child, families may fall into hesitation. So it has become one of the focus issues to eliminate the obstacle factors of the second child birth given. So here we list 4 related theories. The family's cost-benefit theory divides the cost of childbearing into direct cost and indirect cost. And it holds that as long as the benefit is greater than the cost, rational families will choose to have the second child. Birth order model holds that the people who have already given birth to a child will have different decision pattern. So the change of economic situation, the prospect and the quality of marriage and other factors will affect the decision making of the second childbearing. And according to the externality theory, families' behavior of childbearing have positive externality for the whole society, which leads rational families to have fewer children in order to reduce the cost loss. So the fourth theory is quasi-public goods. So this theory holds that children have the attribution of quasi-public goods, which leads to the insufficient of children. So the theoretical and empirical results are abundant. And based on these theories, a few developed countries which have negative population growth or a very rapid aging process had taken some measures to encourage population to increase. But the fertility rate still stick at a low level. For example, Singapore, which has been committed to increase its fertility rate since the 1980s, only had a total fertility rate of 1.16 in 2017. Chinese fertility did not reach the expected level too. The families are still unwilling or not daring to give birth to the second child. And we want to know why the policy results are not very successful. And I know Lee Kuan Yew, the former Prime Minister of Singapore, had a very good view. He said that no matter how big the house is, no matter how many baby boners there are, the families still only have one child. He said that it has nothing to do with economic or financial factors. The key is that people's values and lifestyle have changed. So nowadays, more and more people think that childbearing behavior is not a matter of individuals or families, but also a kind of social behavior. But how could we integrate this idea into the theoretical model? So In this paper, we would like to answer the following questions. The first is, does a single family birth given decision is independent or not? Or is it affected by other families or other systems? The second question is if the answer of the question 1 is yes, how does it play its role? So we have the following two hypotheses. The first is that we assumed that the social welfare environment affect the family's second child birth decision significantly. The second is family's self-evaluation of economic status have a significant impact on the second child birth decision. We set up a complete information static game metric, and we try to consider the interaction effects between multi-families by adding the future social welfare into its payoff function. The research subjects are family A and 2, who had already have one child and are still in childbearing age. These two families have the same behavior strategies, giving birth or not giving birth to the second child. And the red underlined part is the payoffs of A, and the blue part is payoffs of B. As for family A's payoffs, KA is sorry. KA is a disposable fertility fund for family A, and sorry, KA is a disposable fertility fund of family A, and CA represents the cost. So KA minus CA is the balance of the fertility fund. And if the family A cannot give birth to the second child, CA will disappear from the payoffs, and that will increase family A's consumption in the future. UA indicates the expectable satisfaction from the second child, such as economic feedback and old age care, etc. WI represents the level of social welfare that A and B could enjoy in their old age, which including comprehensive social welfare, pension system, etc. And in order to reflect the different three kinds of social welfare in different fertility level, it is assumed that W1 equals 8, W2 equals 2, and W3 equals -4. In case 1, we assumed that the income and parenting costs of the two families are the same. If the payoffs here we assumed are consistent with the general situation, we will get the Nash equilibrium of 8-8. So which means both A and B will not give birth to the second child. If we sort out these conditions, we will find some important inequalities. So if all the 4 inequalities hold at the same time, the rationality of families will lead to the irrationality of the whole society, as the matrix falls into the prisoner's dilemma. So in case 2, we assumed that the income and parenting cost of the two families are different, and other external conditions are identical with case 1. And now the Nash equilibrium should be 23-14, and which means the higher income family is willing to have the second child. That's because the richer family can spend more on elite education, and so that they can ensure that both of their children have good social status in the future. So if all the above four inequalities hold at the same time, more children will be born than in case 1. In case 3, we assumed that the family does not think the social welfare will change, which means the future social welfare will be equal. Here we assumed it will be 0, and other internal conditions are identical with case 2. So now the Nash equilibrium is 24 and 12. Although it's a prisoner's dilemma, but all the families and the whole society will have achieved the parental optimality. So if we check the game matrix, we will find that the matrix have been degenerated to a simple cost-benefit model. And but people think that the personal optimal is also the social optimal, but it may be just a misjudgment, which due to the lack of information about the future welfare changing. The theoretical deduction discovered that families' fertility decision is related with fertility utility and cost and capital interest rate, and also different social welfare levels. If W1 bigger than W2 and bigger than W3, even if U minus C less than 0, as long as U minus C is still bigger than W2 minus W1 and W3 minus W2, the families may still choose to give birth to the second child. Based on the logical deduction of the game matrix, the logistic regression model was established as follows. Here we measure social welfare with endowment insurance and medical insurance, and we measure income gap with self-assessment of economic status. X means the controlled variables. So the estimates are showed here, and by now we got 3 conclusions. Okay, these conclusions have been mentioned more or less before. As we have no more time here, I'd like to skip this part. And we give several suggestions here, such as promoting feline piety culture and advocating economic feedback, as well as reducing the children's education fee and medical expenses, and encouraging researchers to simulate the economic development and social welfare level in long terms with different fertility scenarios. We think the above measures may help to approach an ideal fertility level. Okay, that's all. So it must be some mistake in this presentation, and I hope to get your opinion. Thank you. Thank you.
Okay.
Okay, thank you.
Can I ask a question? can I ask question? Yes.
Mhm.
Okay. So you consider static game, but this game is repeated in times. So you show that the equilibrium depends on the income of people. So if low income, the equilibrium is the following. If the solution of people depends on the income, but it is repeated many times. So it's better to, so first step is okay, but now after that I recommend you to apply evolutionary game theory, because in this case you can forecast what it will be in future in equilibrium policy. So you can divide the population of China for some groups, depending on income, on some parameters. And after that, people will move from one group to another group. So evolutionary game theory can help you to say what will be in China after 10 years, 20 years, etc.
Yes, yes. Thank you for your question. I don't know if I understand it completely or just partly. In my model, I try to divide the people by the locations, such as relatively developed area and relatively undeveloped areas. And I also divide people by cities and countryside. I assumed that the peoples in these different places have different social welfares because it is unbalanced in China. Yes, in this area. So after this kind of treatment, I try to model it, and I find it really it really focus on the different. Yes.
Okay.
Yes. Yeah. Thank you.
Thank you.
Mhm.
Okay, thank you. Question from Mazalov, professor. And anybody has questions? Okay. Thank you. If nobody,
Sorry, I have a question.
okay, please.
Maybe it's also a question, and maybe comment at the end slash question to the comment of Professor Mazalov. So, is it possible to consider?
Sorry, I cannot I cannot hear you.
Простите, ничего не слышу.
Now you cannot hear me?
Okay.
Right now it's okay.
Okay. Maybe it's also a question to Professor Mazalov and you both. But anyway, it's interesting. Is it possible to consider a repeated game scenario, or it is less important here for this specific applied problem? Because it seems that as generations come, this game repeats.
Yeah. Yes. Repeated. It should be repeated, and people may learn some behaviors from other people too. And yes, I can do some improvement in the future by using the repeated game metrics or some kind of other method. I will try to improve it.
Oh, okay. Actually, maybe you can use some good resources we can recommend you about repeated games, or even we could recommend the online course where you
Yeah.
have a small part. But one thing about repeated game, actually I'm still interested how to apply evolutionary game, but I'm not specializing in it. But for the repeated game, it is important that there the main assumption, one of the assumptions is that players
Mhm.
will forecast their actions for a very long time ahead, for all
Yes,
the
yes.
generations ahead. So when we construct the Nash equilibrium in or some other type of solution in the repeated game, we think that the players will consider their actions for infinite horizon and infinite number
Yeah.
of stages. But maybe in your model, it's not like this, because if each stage is the generation, then people, there are very few number of people, very
Yes.
special people, who think for maybe 100 generations ahead. Of course, these people are very great, but usually people think for 1 or 2, maybe 2 generations ahead.
Yes, yes.
Maybe
Simple.
3 generations ahead, but not more. And
Yeah.
because even it's impossible to take into account all the factors. So this kind of approaches, I know colleagues that have developed this approach in Moscow State University, and actually this approach is kind of close to the continuous updating approach, when we have a time window. Even for repeating games, their time window to look ahead, that the agents are looking ahead. So that is this idea for repeated games come from in some sense that is very similar to the continuous updating approach. But I think you will listen to this later in the presentations.
Okay. Thank you. Thank you. I will. Yeah. Yeah. Thank you.
So you study the real data, right? From the
Yes.
okay.
Real data.
Oh, it's very interesting. Thank you very much. Very interesting.
Thank you. Thank you very much.
For Russia, it's also very important, but we need to increase. In Russia, we need.
Yes. Also, yeah. I have mentioned that Russia has this problem too.
Yeah, but we have yes, it's very important for Russia as well. Thank you.
Yes. Thank you.